company make the education more practical oriented and bring confidence and passion among students towards education. With this vision in our mind, we are going to enjoy this video on playing with microcontroller. This is a series of videos on microcontrollers and we will take you from basic to a black belt position. This is first video of this series, getting started with microcontroller. If you want to be a successful embedded engineer or you want to create wonderful things, this is a right course for you. Here is the lecture flow of this video. First is introduction, then prerequisite, then setting your own lab, then compiler and programming software, programmer, development board, introduction to ATmega32, breaking LV experiment, make your own harmonium, what next to learn and do. With this, we will move to our first topic, that is introduction to microcontroller. Microcontroller, I think, is one of the most interesting subjects for every engineer, especially with electrical, electronics, mechanical and computer branch students. It empowers you to create wonderful things. What makes it so important is its ability to get program and to meet the design requirement with a great precision and in a very efficient way. Microcontroller is everywhere. You just look around yourself, like in your home. You have a TV remote, you have a set-top box, you have a computer, you have a keyboard, you have a mouse. In your kitchen, we have a microwave oven, and we have washing machine. And you go for shopping, and there you will see digital weighing machine, your barcode scanner system, your RFID system, and the control for your lift and escalators. You go somewhere by car, bike or bus, you will have a microcontroller based system all along the way. And if you go to any industry, you will find the automatic system there, robots working 24/7 with the help of these microcontrollers. And if you are working in an office or some institute, you will find the fingerprint based attendance register. So microcontroller is everywhere. It is embedded into every system. That is why we call it an embedded system. Now we will move to our next topic, that is prerequisite for this course. So first is you should have a good knowledge of C programming and you should be familiar with for loop, while loop, else, if else loop, and arrays and pointers, and the logics like and OR gate. And you should have good knowledge of electronic circuit, electronic components like resistor, capacitors, transistors, op-amps. You should have good knowledge of digital electronics circuit like multiplexer, your shift register, your decoder, etc. You should have good knowledge of computing system like your binary and hexadecimal number representation system. And finally, and I will say the last but not the least, lots of passion and patience for this. Please make it clear that learning microcontroller is not a sequential process. If you have a mastery on first subject, then only you can go to some next subject like that. So here you can anytime you can go backward, learn it, and then go ahead. With this, we will move to our next topic, that is setting your own lab. I think the most amazing part of this microcontroller is that it doesn't require a heavy investment for setting your lab. It just takes around 3,000 bucks and you will have a wonderful lab with you, and you can be a successful or very good embedded engineer, but provided you are dedicated for this. Just like a cricket bat doesn't ensure you to be a successful cricketer, So here also you have to play with microcontroller. So here is my wonderful embedded lab. So this one is programmer. This is used to program to burn the hex file into the microcontroller, and this one is development board, and which has microcontroller, and it has other interfacing peripherals like buttons, your RTC, your LM35 sensor, and like your LCD display, your SD memory card, and you require a multimeter for checking signals, and you require this soldering iron and soldering wire. You require general PCBs on the breadboard for doing experiments, and for some projects you may require an oscilloscope or a function generator. But if you don't want to invest on that, you can turn your headphone into your function generator and oscilloscope with the help of software which will run on PC. And you also require some discrete components like resistor, capacitors, transistors like BC547, etc. And you require a power supply for powering up this development board, and you may also require some wires for doing experiments. And besides that, you should also read good books, standard books, like we have 8051 by Majidi. You can also read Electronic Principle by Molvino, and you can also visit websites regarding the microcontroller, and you will get a very good knowledge regarding this subject. And if you have any doubt, any clarification, any problem, you can always contact us, and we are always ready to help you and to solve your problem and to guide you. With this, we will move to our next topic, that is compiler and programming software. There are many compilers available for AVR microcontrollers. Like we have AVR Studio and Programmer Notepad. We are using Programmer Notepad. It's completely free. You can download it from our website. It is very simple to install it, but still, if you have any doubt, you can always contact us. With this, we will move to our next topic, that is programmer. So the question is, what is programmer? So programmer is a device which will load, or we can say burn, the hex file generated by a compiler into a microcontroller. We have different programmers available in market. We are using this USB ASP programmer. Okay. And it can program AVR microcontrollers like 80MB8, 16, 80MB32, 80MB88, like that. To use this programmer, you are supposed to have this USB ASP driver software saved in some folder on your computer. You can get the same from our website. Now, when you first plug this programmer into USB port of your computer, it will ask for the location of driver. Then you have to give that required location, and then you have to follow some simple steps, and now your programmer will be ready to work. There may be a case like when you plug in and it doesn't ask for any driver to be installed. Then what you have to do, you have to go to device manager, and then you will find that libUSB thing there, and then you have to click that, and then you will find USB ASP. You have to right click it and then go for update driver, and then again it will ask for the driver location, and then you have to follow the simple steps. If you have Windows XP, there won't be any problem, but if you have Vista or Windows 7 or Windows 8, you have to first temporarily disable the digital signature verification, because this driver is not digitally signed. And if you have any doubt, if you require any assistance, you can visit our website. There we have explained all this process in a very step-by-step manner. Now moving to our next topic, that is development board. If you are new to microcontroller programming or you are designing some prototype, it is good to have development board with you because it will save lot of your time and energy. When you are done with programming part of the project, you can make a transition to like a PCB or to your breadboard. Here we have this wonderful development board from embeddedmarket.com, a Pune-based company. This one is programming board for connecting the programmer. It is used to program this microcontroller. This one is ATmega32. Here we have 4x4 keypad, and here they have provided these four extra buttons here. This one is RS232 IC, and this one is DB9 port. This section is used for interfacing this microcontroller to your PC. And here we have micro SD card slot. The connectors of this slot is coming here, so we can connect microcontroller pins to this connector, and we can interface with micro SD card slot. We can save the reading into your SD card, or we can this microcontroller can also read it from this micro SD card slot, and it can display the data on this LCD display. And this one is a power section. Here we have a power converter, and it is converting. We are getting here 12 volt DC, and this circuit is converting this 12 volt into a plus 5 volt supply, which is used for powering this whole development board. Here we have this LCD 16:2 LCD display, and all the connectors of this LCD are coming here. And here we have this RTC chip DS1307, and here we have EEPROM. Here this one is buzzer. This one is infrared sensor, so we can interface the microcontroller with the TV remote. And here we have LM35, the temperature sensor, and here they have provided these 8 LEDs. So if I want to connect PB0 pin of this microcontroller, so to this LED I can easily connect with the help of this connector. Now moving on to our next topic, that is introduction to ATmega32. ATmega32 is a wonderful microcontroller with 32 programmable input and output pins. It has 8 channels of 10-bit ADCs, that is analog to digital converters. It has 32 kilobyte of flash program memory, and it has 1 kilobyte of internal EEPROM memory, and it has 2 8-bit timer and 1 16-bit timer. So our microcontroller comes in different packages like DIP package and your TQFP package. We have a DIP package in our development board. So now we will discuss the pin configuration of this IC. So we will count it from the left side of the notch. So here 1, 2, then 20, then 21 to 40. It has 4 ports: port A, port B, port C, and port D. All has 8 bits. All these pins of these ports, 4 ports, are input-output ports, but they can also use for performing some special functions. Like here, this port A0 to PA0, PA1 to PA7, can be used for as a analog to digital converter. Like we have PD0, PD1, RX, can be used for communication. This int0 and int1 can be used for taking external interrupts. And these pins PB4, PB5, PB6 and PB7 can also be used for SPI communication. This pin number 10 is plus 5 volt supply. We have to connect to the plus 5 volt of power supply to this pin and ground of our power supply to this pin 11. You are suggested to read the data sheet of this ATmega32. You will get all the detail there about its registers, about its interrupts like timer, your ADCs, your PWM, anything you will get there. You can visit our website and you can get the data sheet from there. Now, moving on to our next topic, that is blinking LED experiment. So we will first open the programmer notepad. So we will go to programs and then we will go to WinAVR. Then I'm clicking on this programmer notepad. Now I will create a new project, file, then new, then project, and I'm giving its name LED blinking. Okay. Now I will give location for this project. So I will save in my D file. So I'm making a new folder here and I'm giving name LED blinking. Okay. And OK. Now this is where we have to write the program. So I have with me the files for this blink.c and make file required to run this program. So I will open this blink.c file and I will copy and paste here. Okay. Now I will press Ctrl S and I will save it on my where I have saved this save my project. So it is LED blinking with LED blinking name. Yeah. So I am giving its name blink LED blink.c LED blink.c. Okay. Now I have to add this LED blink.c to my project. So I'm clicking here, right click here, LED blinking, then I'm going to add file and then I have to select this LED blink.c, then I'm getting here. So we'll go to the folder we have saved this project by just right clicking on this window and we will click here open containing folder. Okay, so this is our folder. So we will place here the make file. So Ctrl S and then Ctrl V. Okay. Now I will open this make file and I will do some setting here. So I will open it using this WordPad. So the name of my main file is led_blink.c. So here there is one option for target. Okay, so target is, I will make it here LED blink. Okay, and here as I am using this ATmega32 microcontroller, in case we are using ATmega8, so we have to write here ATmega8 and we can because this one is like 8 megahertz, we can set the clock here. Now I will build this program. For that, now we will discuss about this program led_blink.c. So here we have this portion. These are library files, some header files are there, and here this is main function. Here we have written ddrb. So as we have discussed that it has 4 ports, port A, port B, port C and port D, and we are making the bit 0, that is PB0 of this port as a input port, because it can act like both as input or output. So we are making it a output pin. So this one is ddrb. So this will define the direction. So for making it output, we have to make it 1 here. So now it is an output port, this PB0. Now here it is while loop. So this loop, this is loop forever, and here we have make it this is a port data, I can say. So here I am making it here PB0 as +5 volt by making it 1, this bit 0 of this port B. Then I have given delay of 1000 millisecond, that is 1 second. Then I am making it 0, that is now the voltage level at this PB0 pin will be a 0. Then again I have given a delay of 1 second, and then this loop will repeat. Now to build this program, what I have to do is, first I have to go to tools, then I have to click on behavior make all. So this one is my output file, output window, and as you can see here, it is compiling, it is building this. Now it has built with no error. Now I will show you to program this. Okay, first I will show you the hex file generated here. So now earlier there was no hex file, and now I have this hex file led_blink.hex. So to program this microcontroller, so what I have to do, I will go to tools here, and then I have to click program here. So first I will connect so I am connecting my programmer here, and it is ready to burn this hex file into this microcontroller. So I am pressing here program button. Now okay, now it has been programmed, and now I will connect this PB0 pin to any of these LEDs. So you can see it is blinking. Now moving on to our next topic, that is make your own harmonium. So first we will play with this harmonium, and then we will make electronic harmonium. So basically we have 7 notes in our music. One is sa, re, ga, ma, pa, dha, ni, and then last sa is high pitch sa, high frequency sa. So I will play for you. So sa re ga ma pa da ni sa ni dha pa ma ga re sa. Now we will play our own electronic harmonium. So we have this headphone with us, and we have this microcontroller program for this tune. So it will go from sa re ga ma pa da ni sa and then sa ni dha pa ma ga re sa. Now we will understand the science behind harmonium. So there are 7 notes, sa re ga ma pa da ni, and the last one is sa, capital Sa, we can say. So each note corresponds to different frequencies. So here we have written here the relation between all these notes. So these are called saptak, sa re ga ma pa da ni. So if we set frequency of Sa as 300 Hz, so re is related to Sa by this, around this formula, ga, and like this. So if it is 300 Hz, then it will be 337 Hz, this one will be 378 Hz, and this one is 401, like that. And now we will calculate the time period of each node by taking the reciprocal of the frequency. So here I am getting the time period. So it is in microsecond here. So like time period for Sa is 3333 and for Re is 2967, like that. Now we will discuss how to generate a frequency corresponding to any node. Say here in this example we are generating a square wave frequency for this node Ga. So for Ga the frequency is 378 Hz. Now we will calculate the time period of this square waveform by reciprocating it, by taking reciprocal of this. So it comes to be 2645 microsecond, and from that we will calculate the half time period, that is 1322 microsecond. So to generate this frequency, so we have to keep the output status of this port B 0 pin as high for 1322 microsecond, and then again low for next 1322 microsecond, and then we have to repeat this. So now come to the programming part here. So here we are making it at level 5 of this pin 0 of port B here, and then we have given a delay of 1322 microsecond. Then we make it 0, we bring it at 0 level, at ground level, and then again we are giving a delay of 1322 microsecond. So in this way we will get a square wave corresponding to note Ga. Similarly we can do it for the other notes, sa re ga ma pa da ni. Now coming to our final topic, that is what next to learn and do. So in our coming videos we are going to learn the following. We will interface with LCD display, with 7-segment display, with the 4x4 keypad, and we will also interfacing with the PC through RS-232 port, and we will also interface with the 4x4 keypad, and we will do many other things with lot of cool and innovative experiments. Please let me know your feedback regarding this video. If you have any doubt or clarification, please contact us. We will be glad to help you. We will meet in our next video. All the best and happy programming.